Our today's topic is operations on real numbers. First thing which comes in your mind is, what do you mean by real numbers? In our last class, we have talked about decimal numbers, how they are terminating, non-terminating, and the non-terminating are again repeating, non-repeating. Non-terminating, non-repeating decimals are called irrational numbers. So now when we talk about real numbers can be divided into two: rational and irrational. Rational means which can be represented in the form P by Q. Okay? Irrational. What do you mean by irrational? Like I said, root 2, root 3, root 4. Sorry, not root 4. Why root 4 is not an irrational number? Because it's a perfect square number. We get the number 2. So perfect square numbers are never irrational. Inside root, if we have non-square number like 7, 8, 15, 17, any number which is a non-square number and it is inside root, square root. So such numbers are called irrational numbers. Instead of using the word irrational again and again, in my videos I'll be using the word surd. Surd. S-U-R-D. Surds are irrational numbers. See, till now you have been dealing with only rational numbers. Now for this topic to be thorough to you, you should know how we operate on surds. Like I'll take some basic addition, subtraction, multiplication and division operations on surds. Any irrational, rational number or two irrational numbers, if they multiply, add, what happens is, firstly, for surds, root 2 and 3 root 2, we say they are like surds. Why like surds? Because inside root, if same number is written, so they are like surds. Root 2 means 1 root 2 and this is 3 root 2. So they are like surds. If I say root 3 or 4 root 2, are they like surds? No, they are unlike surds. Because it's root 3 and this is root 2. Suppose I say minus 4 root 2 and plus 5 root 2. Are they like surds? Yes, they are also like surds. Because inside root, if same number is there, so they are called like surds. See, when like surds are there, you can add or subtract them. Okay? But when unlike surds are there, you cannot add or subtract. But multiplication and division is possible for all the surds. Now I'll be explaining you how to operate. If I take the number minus 7 root 2 plus 6 root 2, then 7, I'll take another 5 root 3 minus 6 root 7. Here root 3 plus root 2, root 5 minus root 5, 3 root 5 plus 6 root 5 minus 3 root 5 plus 6 root 5. These are some of the basics addition and subtraction operations with surds. See, are they like or not? They are like surds. Okay? So we don't have to add the numbers inside root. That will be written as it is. Just the number which is before root will be added or subtracted as per the rules of integer. Minus plus minus sign of greater number. So minus 7 plus 6 will be minus 1. So we need not write 1. It means this is minus root 2. It's same as it's minus 1 root 2. Okay, for 1 you need not write. Now next is, are they like surds? No, they are not like surds. Because here inside root there is number 3 and here there is number 7. So can you add or subtract them? No, you cannot add or subtract them. It will remain as it is. Here, are they like surds? They are also not like surds, correct? So we'll write the number as it is. Now here, they are like surds. Nothing is given, matlab it's 1 root 5 and here it's minus 1 root 5. So plus minus minus sign of greater number, plus 1 minus 1 will be 0. So no need to write 0 root 5. 0. We can write it down as 0. Now here they are like certs. Yes, they are like certs. What will you do? Root 5 write down like root 5 only. You don't write root 5 plus root 5 root 10. No, it's wrong. For addition and subtraction, whatever number is given inside the root, you have to write down as it is. Now you have to add or subtract the number which is given before this. So 3 plus 6 will be 9 root 5. Now minus 3 root 5 and plus 6 root 3. Can you add or subtract them? No, they are unlike surds. The answer will be same. Got it? For addition and subtraction, the surd should be like. Then only you can add or subtract them. You need not add these surds. You have to add or subtract the numbers which are before these surds. And the same rule as we used to apply for integers, same thing we have to apply. Plus minus minus sign of greater number, minus plus minus sign of greater number, plus 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 sign will be plus, and minus minus plus sign will be negative. But here instead of addition and subtraction, if I write down multiplication, then how will you do? See, look at these very carefully. See, here you have to multiply the surd with the surd and the number with the number. You don't have to multiply this number with this surd or this number with this surd. No, surd will be multiplied with surd only and the number will be multiplied with number only. So minus 7 multiplied by 6 gives you minus 42. Okay, and root 2 into root 2 gives you root 4. So here instead of root 4 you can write down as 2. So this number becomes minus 84. Got it? See, any number can be broken into two parts. Any natural number. Like if you want to break 6, you can break it into two parts. Root 6 and root 6. Root 6 into root 6 is root 36, which is equal to 6. For breaking a number into two parts, like 7, you can break it down as root 7. Okay? So, any surd multiplied by the same surd gives you the natural number. Like root 13 into root 13. What will you get with? 13. Okay? Root 3 into root 3. What will you get? 3. Because root 3 into root 3 is root 9. And root 9 is 3. Root 13 into root 13 is root 169 and root 169 is 13. Proceeding further, see, as I told you, the number will be multiplied by the number and the surd will be multiplied by the surd. So 5 into 6 gives you 30 and root 3 into root 7 gives you root 21. And these surds should be written in very simplified way. This I'll be telling you next. Now root 3 into root 2. This gives you root 6. Here the number is 1. Here also it's 1. 1 multiplied by 1 is 1. Now root 5 into root 5. Can you tell me orally what will be? Just now I said a number can be broken into two parts. So root 5 into root 5 will be 5. You can directly write it down. Why? Because root 5 into root 5 is root 25. And root 25 is 5. Now here comes 3 into 6, 18. And root 5 into root 5, 5. Can you write down directly? Yes. Now it's 90. Minus 3 into 6, it's minus 18. And root 5 into root 3, it's root 50. Okay? Have you understood these concepts of multiplication? Same is the case with division. See, similarly, you have to write for division. Like I say, 7 root 6 divided by 2 root 3. Yeah, 81 root 5 divided by 9 root 5. Or 72 root 7 divided by, you can take it as 21 divided by 12 root 3. What will be the answer? See, as I told you in multiplication, numbers will be divided by numbers and the surds will be divided by surds. So 7 by 2 gives 7 by 2, yeah, 3.5. Need not convert into decimals. You can directly write down as 7 by 2. And root 6 upon root 3. See, root 6 by 3. Like this you can write it down. So this becomes 7 by 2. And got it? Because surd can be divided by surd. And root 6 divided by root 3 is root 6 by 3. That is root 2. So our answer is 7 by 2 root 2. Now here 81 root 5. See, 9 nines are 81 and root 5 gets cancelled because root 5 by 5 1 and the square root of 1 is 1. So we'll write only 9. Next 72 root 21 upon 12 root 3. 12 ones are 12 6 are, and this will get cancelled. This becomes 6 root 7 because root 21 by 3 gives you root 7. Have you understood? Even if there is my negative sign, you can put the negative sign as we used to do earlier. Now we'll be doing, this were simple surds, singular surds. Now we'll be doing with, as we have studied, binomials, means 2 term, a trinomial, 3 terms. Similarly, some complex surds and all. How to operate with them? Add, it's given, add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. How will you add them? See, 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. First we have to arrange so that like surds are next to each other. So 2 root 2 plus root 2 plus 5 root 3 minus 3 root 3. Now how will you add them? Can you add them? Yes, they are like surds. The number inside root will be as it is. In case of multiplication and division, we have to divide and multiply. But in case of addition and subtraction, the number inside the surd will be as it is. Now here the number is 2. If nothing is given, it is 1. So 2 plus 1 will be 3. So 2 root 2 plus root 2 becomes 3 root 2 plus. They are like surds. You can add and subtract. Root 3 will remain as it is. 5 minus 3 is 2. The answer comes to 3 root 2 plus 2 root 3. Now the next question is multiply 6 root 5 by 2 root 5. How will you multiply? The number will be multiplied by the number and the surd will be multiplied by the surd. So 6 into 2 becomes 12. And root 5 to root 5, chalo jaldi, jaldi. What it comes to? Yes, it's 5. So this is 60. Now next is divide 8 root 15 by 2 root 3. Same is the case with division. As we have done in multiplication, the number will be divided by the number and the surd will be divided by surd. So 2 ones are, 2 fours are, root 3 ones are, root 3 fives are. So it comes to 4 root 5. Here we have done with single terms. With these examples, we can conclude that the sum or difference of rational and irrational number is always irrational. Can you give an example of it? What did I say? The sum or difference of rational and irrational number is always irrational. Take any two numbers. Take one as rational and the other as irrational. See, I take one as number 2. This is rational number. And other as irrational. I take it as root 3. Sum. Can you add them? No, you cannot add them. They are unlike certs. So the number remains 2 plus root 3. And 2 plus root 3 is irrational number. Because you cannot solve it further. Again, the difference of a rational and irrational. You can take these as examples. They come for 1 mark question in the exams. So the difference 2 minus root 3. Can you solve it further? No. It remains as it is. So this is also an irrational. So what do we conclude? The sum or difference of rational and irrational number is always irrational. Similarly, the product or quotient of non-zero rational number with an irrational number is also irrational. Now what do you mean by this? The product or quotient, matlab if we multiply or divide, why did we say non-zero rational number? See, take a zero rational number. Zero rational number means 0 and an irrational number means take it as root 3. If we multiply, we get the answer 0 na. So it is rational or irrational? This is rational because 0 can be written in the form 0 by 1, that is p by q. Got my point? What did I say? The product or quotient of non-zero rational number. The number should be non-zero. You can take the number as 1, 2, 3, 4, 5, 15 by 16, 20 by 30. Any number you can take. With an irrational number is always irrational. See, take any non-zero rational number. I take down as 3 by 2. And an irrational number I take down as root 7. So what I get is 3 by 2 root 7. Again this is irrational. Got it? So product or quotient of non-zero rational number with a rational number is always irrational. Similarly, the sum or difference of rational and irrational is always irrational. Now the last point is, if we add, subtract, multiply or divide two irrational number, the result may be rational or irrational. Now how can we say this? If we add, subtract, multiply or divide two irrational numbers, the result may be rational or irrational. Take any two rational number. I take it 3 and 3. Root 3 and root 3. See, if I add it, I get 1 root 3 plus 1 root 3 is 2 root 3. If I subtract it, I get 0. If I multiply it, I get root 9, that is 3. If I divide, I get 1. So, I got irrational, rational, both the numbers I got. Now, you can take any other number. Just say 2 plus root 3. This is irrational. 1 is 2 minus root 3. This is also irrational. If we add them, I added. So, root 3 and minus root 3 gets cancelled. I got 4. This is rational. Okay. So, multiplication, division, addition and subtraction of two irrational numbers can be either rational or irrational. With this, we will be doing some more complex operations with certs using polynomial identities also. What all identities we have used in our 8th standard? A plus B whole square is A square plus B square plus 2AB. A minus B whole square is A square plus B square minus 2AB. A plus B, A minus B is A square minus B square. One more identity which you have used is X plus A x plus b is x square plus a plus bx plus a into b. All these identities will be same when we take two rational or irrational numbers. So starting with it, 5 plus root 7, 2 plus root 5. How will you solve it? See, here none of the identities hold. So what do you have to do? Multiply each term with each term. So with 5, you have to multiply 2 plus root 5. Then with plus root 7, you have to multiply 2 plus root 5. Got it? Each term with each term. Now, 5 into 2, 10. Rational. 5 into root 5. See, when we multiply, the whole number gets multiplied with the whole number and the surd with the surd. Here there is no surd. Here there is root 5. So 5 into 1, 5, and root 5 will remain as it is. I'll do a rough work over here. See, if nothing is given, it means that there is 1. 5 into 1, 5. And here there is no number in the root, means it is root 1. So root 1 into root 5 is root 5. Similarly, root 7 into 2. 2 will be multiplied with 1, we get 2. And root 7, there is no number in the root. So we consider it is root 1. So we get root 7. Plus, multiplying a surd with a surd, you get root 35. Got it? Here, is there any like term? No. All the numbers are different. So this is our final answer. Next.